Welcome to today's lesson. Our topic for today is specific heat capacity. Recall, in our previous lesson, we dealt with heat capacity, and we defined heat capacity as the quantity of heat required to raise the temperature of a body by 1 Kelvin. Today, I want us to look at the specific heat capacity, which is almost the same thing with that, and it is the quantity of heat required to raise or lower the temperature of unit mass of a body by 1 Kelvin or 1 degree Celsius. Now, the interest here is on unit mass, and of course, unit mass is 1 kg. So we can also say that specific heat capacity is the quantity of heat energy required to raise or lower the temperature of mass of 1 kg by 1 degree Celsius or 1 Kelvin. It is represented mathematically by the equation Q is equal to mc delta theta, where Q is mass of body. Sorry, where Q is the quantity of heat energy measured in joules. Delta theta is temperature change, and of course is measured in Kelvin. Cp is the specific heat capacity of the body. Of course, we will find the SI units. So, the SI units of Cp can be obtained from this formula. By making Cp the subject, Cp equals Q all over mass times temperature change. And of course, Q is measured in joules, mass is in Kelvin, mass is in kg, and temperature is in Kelvin. We now have that the SI unit is joule per kg per Kelvin, or it can be written as joule per kg per Kelvin. Okay, let us see one of the problems to solve. Example 1. The temperature of a piece of metal of mass 0.92 grams is raised from 5 degrees Celsius to 85 degrees Celsius when it absorbs 108 joules of heat. Calculate the specific heat capacity of the metal. Solution. We have the parameters already, so all we need to do is to list them out. Mass of the metal is 0.92 grams. And of course, the SI unit of mass is kg. We convert it to kilogram by dividing it by 1000. 0.92 all over 1000. It will give us 0.0092 kg. Okay. Now we have 3 zeros before the 92. Now it's raised from the initial temperature, theta 1 is 5 degrees Celsius, while the final temperature there is 85 degrees Celsius. Quantity of heat absorbed in the process is 108 joules. We now have our formula as Q equals mc delta theta. We solve for delta theta first. Delta theta equals theta 2 minus theta 1, which will give us theta 2 is 85. 85 minus 5 will give us that delta theta is 80 degrees Celsius. Now, we substitute Q, the value of Q, 108 equals Cp is what we are looking for. So we have it as mass 0.00092 times Cp, then times 80. Okay, 108 equals 0.0092 times Cp times 80 will give us, by calculation, 0.0736 Cp. Now let's CP the subject. Cp will give us 108 all over 0.0736. And the final answer, by calculation, will give us 1467.4. Therefore, the specific heat capacity of this piece of metal is 1467.4 joules per kg per Kelvin. Okay, we take the second example. 2. Calculate the final temperature of 2000 grams of alcohol at 25 degrees Celsius when 20,160 joules of heat energy is added to it. Solution. And of course, the specific heat capacity of alcohol is given to us as 2,520 joules per kg per Kelvin. Okay. As usual, bring out the parameters given. Calculate the final temperature. That means theta 2 is what we are looking for. Mass is 2,000 grams. And of course, 2,000 grams, this one is in kg. We return it. But if it is in grams, we leave it in grams. So since it's in kg, we have 2,000 over 1,000, which will give us 2 kg. Now, initial temperature, theta 1 is 25 degrees Celsius. Now, the quantity of heat there, Q, is 20,160 joules. And of course, Cp is given to be 2520 joule per kg per Kelvin. Okay. Our formula is Q equals mc delta theta. So since we have mc delta theta, we are going to expand this. If we expand this, we have theta 2 minus theta 1. So we now have a Q equals mCp times theta 2 minus theta 1. So we substitute now. Q is equal to 20160 is equal to mass. Mass is 2 times specific heat capacity, which is 2520, into theta 2, which is what you are looking for. We now have it here at theta 2. One on theta 1, which is 25. Bring this one down. 2160 is equal to 2 times 25, 2,500 will give us, by a calculation, to give us 5040. Now we'll bring this one also, theta 2 minus 25. Expand this. By expansion, we have 20160 is equal to 5040 times theta 2 give us 1040 theta 2 minus 5040 times 25. By calculation, it will give us 126000. Now, collect like terms. We'll collect like terms. This one will come over, and of course, once it comes over, this minus will change to plus. We now have 20,160 plus 126000, which is equal to 5040 theta 2. Add these two values. If we add them, we have 146,160 is equal to 5040 theta 2. Make theta 2 the subject. Theta 2 will give us 146,160 all over 5040. Now, this one cancels this. Theta 2 will now give us, by calculation, we have 29.0 degrees Celsius. Okay, this is the end of our class. Thank you very much. Please subscribe so that once we upload new lessons, you will get notifications.